Good morning. I am Regina, Assistant Professor, Department of Mathematics, Rohini College of Engineering and Technology. Today I am going to explain the concept diagonalization of a matrix by orthogonal transformation. Course outcome is, after completing the course, the student is able to apply the concept of orthogonal transformation to diagonalize the given matrix. Diagonalization of a matrix by orthogonal transformation working rule. First, find all the eigenvalues of the symmetric matrix and then find the eigenvectors corresponding to each eigenvalue. Third step is find the normalized model matrix N having normalized eigenvectors as its column vectors. Fourth step is find the diagonal matrix capital D, it is equal to N Transpose AN. The diagonal matrix D has eigenvalues of A as its diagonal elements. So we can see this problem, diagonalize the matrix this. So first we have to find the characteristic equation, lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. So S1 is sum of the main diagonal elements. Main diagonal is this one, 2, 1, 1. We have to add these three elements. 2 plus 1 is 4. S2 is sum of the minus of the main diagonal elements. Minus means you have to first choose the diagonal element, remove the corresponding column and row. We get this 1 minus 2 minus 2 1. Find the determinant for this one. Plus next minor for this one. Next diagonal element 1 is. So we have to remove the corresponding column and row. We get 2 minus 1 minus 1 1. Plus find the minor for this one, the last diagonal element. Remove the column and row. We get this 2 1 1 1. Solve this determinants to 1 into 1 minus 2 into minus 2 plus 2 into 1 minus 1 into minus 1 plus 2 into 1 minus 1 into 1. We get this minus 3 plus 1 plus 1, that is equal to minus 1. Next to find the determinant for the given matrix, that is S3. So how to find the determinant? So first write this 2 into, remove the column and row, 1 into 1 minus 2 into minus 2, 1 into 1 1 minus 4 minus, this is plus minus plus, minus 1 into, remove the column and row, 1 into 1 minus 1 into 1 1 minus 1 into minus 2 2 plus minus 1 into, remove the column and row, 1 into minus 2 minus 2 minus 1 into plus 1 plus 1, that is equal to 2 into minus 3 minus 1 into minus 1 minus 1 into minus 1 minus 6 plus 1 plus 1. So the answer is minus 4. So the characteristic equation is lambda cube minus S1. S1 is 4. 4 into lambda square minus S2 into lambda minus lambda plus 4 equal to 0. Next we have to solve this cubic equation. After solving this here by synthetic division we can solve this. Write the coefficient of lambda 1, coefficient of lambda square minus 4, coefficient of lambda minus 1, constant 4. First we can check by 1. So here put 1, add this to 1, multiply this and this 1. So add this minus 3, multiply this 1 into minus 3 minus 3, add this minus 4, 1 into minus 4 minus 4. We get 0. If we get 0, this is a factor. Okay. So lambda equal to 1. So the remaining is constant lambda square. So lambda square minus 3 lambda minus 4 equal to 0. So here multiplication minus 4, addition minus 3. The factors are 1 and minus 4. So lambda plus 1 into lambda minus 4 equal to 0. So the factors are minus 1, 1, 4. So next find the eigenvectors corresponding to the eigenvalues minus 1, 1, 4. So first find the eigenvector for the corresponding eigenvalue lambda equal to 1. To find the eigenvectors, we have to solve this A minus lambda I into x equal to 0. So this is the given matrix. This is A minus lambda I. A, that is a given matrix, minus lambda into I. I means it is an identity matrix. 3 cross 3 identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. So in the diagonal elements 1, 1, 1. So we have to subtract this 1 in the diagonal elements. So 2 minus 1, 1 minus 1, 1 minus 1. Remaining elements are in the given matrix A. So after solving this, we get this equation 2 minus 1, 1. 1 into x1 plus 1 into x2 minus 1 into x3 equal to 0. Second one, 1 into x1, 1 minus 1, 0 into x2 minus 2 into x3 equal to 0. Third one is minus x1 minus 2x2 plus 0 x3 equal to 0. Next we have to solve any two distinct equation by cross multiplication rule. So for cross multiplication rule we have to write the coefficient of the equation 1, 1 minus 1. Repeat once again 1, 1 minus 1. Write the next equation 1, 0 minus 2. 1, 0 minus 2. Again 1, 0 minus 2. Remove this first and last. This is for x1, this is for x2, this is for x3. x1 divided by 1 into minus 2 minus this one, cross multiplication. x1 divided by 1 into minus 2 minus 0. x2 divided by minus 1 minus 2. x3 divided by 0 minus 1. So this is the answer. After simplifying this, minus 2, 1, minus 1. So this is the eigenvector corresponding to the eigenvalue lambda equal to 1. Capital X1 is minus 2, 1, minus 1. Like the same way, we have to find the eigenvector for the eigenvalue lambda equal to minus 1. So in the diagonal element, in the diagonal of the given matrix A, we have to subtract minus 1. So subtract minus 1. So minus into minus 1. So plus 1. So in the diagonal elements, we have to add 1. So we get the three equations. 2 plus 1, 3. 3 into x1 plus x2 minus x3 equal to 0. Next is x1 plus 2x2 minus 2x3 equal to 0. Minus x1 minus 2x2 plus 2x3 equal to 0. Like the previous way, we have to solve by cross multiplication rule. From equation 4 and 5, we get this one. x1 by minus 2 plus 2, x2 by minus 1 plus 6, x3 by 6 minus 1. After simplifying this, x1 by 0, x2 by 5, x3 by 5. So 5 is common, so we can divide by 5. So we get x1 by 0, x2 by 1, x3 by 1. This is the eigenvector corresponding to the eigenvalue lambda equal to minus 1. So like the same way, we have to find the eigenvector corresponding to the eigenvalue lambda equal to 4. So for this one, we have to subtract this lambda from the given matrix A minus lambda I. 2 minus 4, 1 minus 4, 1 minus 4. We get three equations. 2 minus 4 is minus 2 x1 plus x2 minus x3 equal to 0. x1 minus 3x2 minus 2x3 equal to 0. Minus x1 minus 2x2 minus 3x3 equal to 0. Similarly, we have to solve by cross multiplication rule. Select any two distinct equations. Here we selected 7 and 8. After simplifying by cross multiplication rule, we get this x1 by minus 2 minus 3, x2 by minus 1 minus 4, x3 by 6 minus 1. Minus 5. Minus 1 minus 4 minus 5, 6 minus 1, 5. Here also 5 is common. We can divide whole by 5. So we get x1 by minus 1, x2 by minus 1, x3 by 1. This is the eigenvector corresponding to the eigenvalue lambda equal to 4. Capital X3 equal to minus 1, 1. Hence, the corresponding eigenvectors are this x1, x2, x3. So, next we have to check for orthogonality. For this, we have to find x1 transpose and x2. We have to multiply this x1 transpose. Transpose means we have to change the column into row and row into column. It is a column matrix, so we have to change into row matrix. x1 transpose minus 2, 1, minus 1 into capital X2. So we have to multiply this. Minus 2 into 0, 1 into 1, minus 1 into 1. So we get 0. Therefore, x1 and x2 are orthogonal. So orthogonality for next to x2 and x3. So we have to multiply x2 transpose and x3. This is x2 transpose. We have to change this column matrix into row matrix and multiply with x3. So we get 0 here. 0 into minus 1, 0. 1 into minus 1, minus 1. 1 into 1, 1. So we get 0. The next we have to check the orthogonality for x3 and x1. For that, x3 transpose into x1. This is the row matrix for x3 is a column matrix. Change into row matrix and multiply with this capital X1. After multiplying this, we get 0. Therefore, capital X1, X2, X3 are orthogonal each other. The next, find the normalized eigenvectors. So for this, so we have to find the square or sum of the squares of these elements. Minus 2 the whole square, 4 plus 1 square plus minus 1 square. So we get root 6. For this eigenvector, we have to find sum of the square, root of sum of squares. 0 square plus 1 square plus 1 root 2. So here also minus 1 square plus minus 1 square plus 1 square, square root of this minus 3, root 3. So we have to divide this element by each term. Minus 2 by root 6, 1 by root 6, minus 1 by root 6. 0 by root 2, 1 by root 2, 1 by root 2. Here also like the same way, minus 1 by root 3, minus 1 by root 3, 1 by root 3. So we get this normalized eigenvector. So normalized model matrix, we have to change this in the form of 3 cross 3 matrix. So next to find N transpose. Transpose means we have to change this column into row and row into column. Therefore, find the diagonal matrix D is equal to N transpose into A into N. We have these 3, N transpose, A and N, multiply these 3. N transpose, this is N transpose, this is the given matrix A, this is capital N, normalized matrix. When we multiply these 3, we get this result. 1, 0, 0, 0, minus 1, 0, 0, 0, 4. These 3 elements are the eigenvalues of the given matrix. 1, minus 4, 4. Some important questions from this topic. Thank you.